What's on your playlist right now?
In my class.
Go to guilty pleasure food.
Ice cream.
Ice cream. Welcome to Face to Face, John.
Thank you.
Thanks for being here. Glad to have you on the show as we continue to talk about the impact of federally funded research. In that vein, can you talk a little bit about yourself and why you pursued your research career in physics?
Yeah, I've been working in the area of high energy particle physics for over 40 years since I was a graduate student. And it's something that I could never quite let go of, this idea that you can collide particles and create new matter out of just the energy that you're using to do that, and then detect it with these complicated instruments and analyze it with computers. It's just something I've never lost the passion for.
It is really fascinating stuff and mind-blowing in many ways. Now, I understand a lot of your projects are funded by the Department of Energy. Can you talk about some of the work that's happening now?
Yep, the Department of Energy Office of Science, which is nearly as big as the National Science Foundation, funds all of the work in high energy and nuclear physics and a lot of other basic energy sciences in the United States. But my work for the last, decades has focused on the big Large Hadron Collider at CERN, the largest scientific instrument arguably in the world. And I'm a member of the CMS experiment. I and over 3,000 of my colleagues all have our names on the papers every time. And we've produced, I think, nearly 1,500 papers at this point since we started running in 2010 or so. The biggest achievement has been the discovery of something called the Higgs boson, which is a manifestation of this eerie field that permeates all of space and time, and it's where we believe the elementary particles get their mass. At least the more mass they have, the more strongly they interact with the Higgs boson. So I led the team that first saw the Higgs decaying to a pair of what's called tau leptons, the heavier cousin of the electron. There's the electron, then a heavier one called the muon. That's in cosmic rays. You could see them in this room passing through right now if you had muon eyes. But then the tau is even heavier, lives for a very short time, and we can detect it in our detectors. And this proves that the Higgs really does, as we say, couple to mass. Mass acts like a charge for the Higgs boson. But there's lots of other things that we've been doing, looking for dark matter, still not at all seen in these experiments. And then we're just looking really into the unknown. We don't know now what we're going to find next. It's a really exciting time.
I remember when the Higgs boson was discovered, and it was such an exciting time in the field, even for people that are not directly practitioners. And it was...
Suddenly everybody knew about that, and
yeah.
CERN, and the great things happening.
Maybe tell the audience what CMS stands for.
CMS is the compact muon solenoid.
Okay.
It is not compact. It's about 6 stories tall. And my joke is that, these are battleship-sized detectors, but, battleship displaces 30,000 tons. These detectors weigh 15,000 tons, so it's more in the destroyer class.
Wow.
That's my
That's
joke.
huge, yeah.
Yeah.
Can you tell us what is UC Davis's role specifically at the Large Hadron Collider, and what?
Well, back in 1993, Professor Winston Koh, who later became dean of the college, joined the CMS experiment, which was just in its very early design stages then, and so Davis has the claim to be one of the founding members of the experiment, and we've been on ever since. With dozens of physicists, many faculty members have contributed, but right now we work on the innermost detector that surrounds the collision point of where the protons collide and gets the first hits from particles coming out. But we also work on the very largest ones that form these giant end caps and detect the muons that I mentioned before. That's our middle name, is muon, and the other word in the title of the experiment is solenoid. Mm-hmm. There's a big magnet, the largest magnetic field in the world in terms of total volume and energy. and it bends the particles so that we can measure where they're going. And so we've contributed to lots of things over the decades. We've been really strongly supported by the Department of Energy Office of Science ever since the beginning.
That's a real point of pride for UC Davis.
It is.
So I congratulate you and your colleagues who've been working on these things and making all these tremendous discoveries. Now, from the scale that you've described of some of the equipment and apparatus, it sounds expensive. So what would be the result of a lack or reduction of federal funding for projects like this?
Right. We think we might have slipped in under the wire in terms of upgrading our experiment right now. Money's coming from Department of Energy and National Science Foundation to build a whole new inner detector and upgrade the outer detectors as well in anticipation of 2029 when the collider is going to go to 10 times more collisions per second. Luminosity is what we call it. And it's high luminosity LHC. We think we can complete construction with the money that we expect to get. And so we're very hopeful right now. If this money were to dry up, and the NSF groups on our experiment are seeing disturbances because of the great changes in NSF, somehow the Department of Energy Office of Science hasn't experienced quite the dramatic cuts that, let's say, NIH for health sciences and NSF have gotten. So it's a little touch and go for the next few years. And of course, it's so unpredictable right now that if the government suddenly decided to just pull all the stops and stop funding science or use it as some sort of political cudgel against the universities, which is one of our really great fears, and I'm sure something that you're worrying about every single day.
Indeed.
Then that would be devastating. The United States would no longer be a solid partner in this international enterprise. So we put in about a third of the operating and upgrade expenses for this experiment. We have a really big presence over there. And we also, the United States contributed to the construction of the accelerator over 10 years ago. And that gave us a seat at the table. We're not a member of the CERN laboratory. We're not a member state, but we are an observer state and have been very welcome. And I don't know, it's a wonderful collaboration with people from all over the world.
And I imagine the impact of a reduction in funding wouldn't just be the experiments and the equipment. There'd be a workforce impact as well. You would have a hard time training the next generation of people
Clearly,
like yourself.
Yeah. It's not just UC Davis. Every campus in the UC system and dozens of campuses across the United States all train their postdocs and graduate students in this field. And this is how they support that, is from these grants from the DOE and National Science Foundation. What happens to them, then they just can't do this work. I don't think we could support students if we don't have the money to do so, much less postdoctoral researchers.
And then U.S. scientific leadership is in severe jeopardy.
Yes.
Yeah. I want to lighten the mood a little bit. And we have this game we like to play called Hot Seat.
Hot Seat.
And that's your seat.
All right.
That just means I'm going to ask you some rapid-fire questions. Okay. I'm looking for a one-word, one-sentence kind of answer.
All right.
Ready?
Yes.
All right. Star Trek or Star Wars?
Oh, that's a tough one. I know you like Star Trek. I love both of them.
I like them both. I always tell people they're different genres, so it's not a real fair comparison. So.
I tell everyone that if you're going to have the Star Trek transporter, though, fund particle physics.
Exactly. That's right. Yeah. Okay, so in an alternative universe, what other job might you be doing?
You know, I really am attracted to medicine, and if I had become a doctor, I think I could have had a great career, too. I think there's just so many fascinating things.
I think that's true for many scientists and engineers. Yeah. Medicine would be an alternative. Yeah. What's the coolest place you've visited?
Oh, my. There's no question. When I go down into this cavern 100 meters underground and go up on the platform and work on the detector at the heart of this experiment, there's nothing like it. It's like the Holy of Holies or something.
Yeah, right. It's like a religious experience
almost.
Yeah. Okay. Favorite hobby?
Believe it or not, I'm a genetic genealogist. I picked that up during COVID, of all things. I never saw myself doing it, but Yeah, it's very nerdy.
Okay. Are you sending samples in and getting the?
Oh, I have mine, and yeah, my sister's into it, and other relatives, and it's really interesting.
Yeah, cool. I ask everybody who comes on the show this question, but what artist or music is at the top of your playlist right now?
Probably something involving acoustic guitar. I play and sing and listen to what I try to play.
Okay. I'm a George Benson fan, so I like that answer. Okay, now it's your turn. Ask me any question.
So, Star Trek or Star Wars? I think I know the answer.
It's Star Trek, but I also do watch Star Wars movies and shows. It's just, as I say, it's different genres. Star Trek is really science fiction. Star Wars is more fantasy in my mind. So,
do you get to still work on your electrical engineering at all, or is that long in the rearview mirror?
I wish I could do more. My last PhD student finished in 2022, and I haven't taken any since then. I still follow the work in the journals and the conferences, but I don't get to do as much of my own work as I used to.
We certainly make good use of the type of thing that you contributed to.
Oh, good.
In the past.
That makes me feel good.
We have tons of electronics.
Yeah. Anything else?
How do you like living in Davis?
Oh, Davis is great. I always tell people it's a charming college town, really the only one with the UC system. And so you get that kind of environment, but you also are close to things like Lake Tahoe or Napa or San Francisco or Sacramento, so you can do city living or skiing or wine or whatever you like in a really easy commute to and from. So I like Davis a lot. Anything else?
In rapid fire form? No, I have a longer question.
I'll take the long question.
So I think there's a real hunger out there for science, and every time we give public lectures, the room's full, right? And so now with the advent of Aggie Square, can we make it into a showcase or forum for the communicating our science to the public?
Absolutely. That's actually one of our motivating factors for building Aggie Square. There is public space available and event space, and we can schedule talks and seminars and workshops, and we'd like to do a lot of that, not just for the neighborhood and surrounding community, but for larger communities that we can invite in to come to these events. So if you're wanting to sign up, I'll get you connected to the right people.
Sure, I'd love to help out.
Fantastic. Glad to hear that. That's really all we have for today. I want to thank you for sitting down with me and having this conversation. It's been fascinating, and I really appreciate and applaud your work. And it's great to shed light on the importance of this federal funding and why it's necessary to keep research going, like the type of work that you do.
It's strange times.
Yeah, very much so. And thank you for watching, everyone. You can learn more about our UC Davis researchers and their work at ucdavis.edu/labs to lives. And we'll see you next time on Face to Face. Go Ags.